A good day. How are you? My name is Neto. I'm the engineering mathematics tutor. Today we're going to talk about the complex numbers. I'm kindly asking to subscribe to my channel so that I can post more videos of mathematics. Thank you. So what I'm going to do here, I'm going to revise your assignment, but I'm going to use similar examples which correspond with your assignment. So I'm not going to use the numbers as it is in your assignment. So I'll just play around with the numbers. Then, which is very important, you must know how to find, how to solve the question. So for my question 1.1, they are asking for what? You are given, right? They are saying write the polar coordinates in the Cartesian form. Yeah, so here what you must know how to draw a Cartesian form if you are given a polar coordinate. So I'm going to give you my own example. Let's say your polar coordinate is 4 and pi over 2. So if you can check here from this polar coordinate here, what is very important, what you must do here, you must know that this 4 represent your radius. And this pi over 2 represent the angle from your x-axis. So that's the thing that which is very important about this. How to draw when you want to draw your Cartesian form. So, but what you must know here, which is also very important, if you check your pi over 2, this one is your radian. So to make our life easier, you can also convert it to what? To a degree. So let's first convert that pi over 2 to degrees. So how to convert it? As you know that pi is equal to 180 degrees. Therefore, if you're given pi over 2 to convert to degrees, I'm going to say since pi is 180 degrees. So you divide it with what? With your 2. Therefore, your angle in degrees is going to be 90 degrees. So which means if it's like this, I can write like this, which means I can write my polar. So now we now know that my radius is 4 and my angle is 90 degrees. So now let's draw our Cartesian plane like this here. Draw a Cartesian plane, our y-axis and what? Y-axis and x-axis. Let's say here 0, 2, 4, here 2, 4, negative 2, negative 4, negative 2, and negative 4. So what I'm going to do here, where is your positive 4? As you can see, your positive 4, as I said, your 4 represent your radius. And your 90 degrees, it's what? Yeah, I converted it I convert from the radian to degrees. It's 90 degrees. So that 90 degrees, it must be from your x-axis, which means it's here. I'm going to show it, as you can see. Yeah, so that is your 90. When you're counting your degree, you must count it from your x-axis. That's the thing that you must know. Then moving in that direction, which is your anti-clockwise direction from your x-axis. So as you can see, I did show your angle, which is 90 degrees. So which means our Cartesian form here, I'm going to draw the line. What is my radius? My radius is what? Is 4. Yeah, so now this is your Cartesian form. As you can see that one, my radius is 4 and my angle is 90 degrees from the x-axis. So this is how you do your question 1.1. I gave you another similar example. So I hope you can be able to solve it. Now let's go to question 1.2. Your 1.2, as you can see, they're saying determine the modulus and argument of the given question. So what you must know is that generally you must know that a complex number, it's given in this setup. It's a plus let's say imaginary number multiplied by b. What you must know that your a represent your real number and your b represent your imaginary. That is your imaginary number. So what you must know, which is very important, How do you find the modulus? The formula for modulus, which can be written like this. The modulus is equal to, it says square root of what? Of a squared plus square root of b squared. So this is how you find the modulus. It's very easy. Now next, you must know how to find out what? Your argument. Your argument is the angle from the x-axis. Exactly. So you must know how to draw the arcant diagram. Yeah, that one we are going to do it as time goes on. So yeah, let's say which formula can you use to find the argument? Your argument, which is going to be your theta, is tan inverse of b over a. Your b, which is your imaginary number, then your a, which is your real number. So this is how you find your argument, which is the angle from the x-axis. So I will go to do this step by step as time goes on also, since now we are focusing with 1.2. So the question which is given on your 1.2, as you can see there, I'm going to give you my own example. I'm going to play with the numbers so that I will not use the same numbers from the assignment. From assignment, they're saying yes, J, then there's open bracket, then there's 1. Let's say here I'm going to use 2 minus I, which is an imaginary number. Let's say let me use 2, that same 2. So let's find our argument and modulus of this complex number. As you can check, this complex number is not in the simplified state, so you need to simplify it by removing the bracket. So here, as you can see, it's like we need to simplify. We need to multiply our j multiplied by 2. What do you get? You get ij, exactly. The next, what do you do? We say that I multiplied by ij is going to be minus j squared multiplied by 2. Now from this step, as you know, what you must know, which is very important from this step here, is that you must know that a j squared is equivalent to -1. As you know that -1, square root of -1 is equal to j. So you must know this is very important when you're dealing with the complex numbers. So what do you do here? Let's simplify, which means since I said j squared is equal to -1, therefore I'm going to continue is equal to, from this step we go here, I'm going to say j multiplied by 2 minus j squared, I can say it -1, then multiply by 2. So which means I'm going to get j2 positive 2. Now this is your complex number. Now let me try to arrange it in order. So it's going to be positive 2 plus your imaginary number, which is your 2. So it's positive 2 plus the imaginary number, which is what? 2. So that is the thing which is very important. So this is now my simplified complex number. So what you do here to make it easy, let's find our modulus. Modulus, as I said, modulus is very easy to find. The modulus, my modulus here, which is like this, is equal to square root of what? Of 2 squared plus 2 squared, which is equal to square root of 4 plus 4. So it's the square root of what? Of 8. I think you can just simplify by using your calculator. So you know that square root of 8 is 2 root of 2. So it's 2 root of 2. I hope it's very clear. It's very easy to find what? Your modulus. So from there, what is next? How do you find our argument? The argument, as you can see, this one, let me try to draw what? The argand. What you call an argand diagram. Your argand diagram, which is like, it's a Cartesian. It's in the form of a Cartesian form. What is very important, you must know that your y-axis this way, you write down your imaginary. Then your x-axis, this is where you write what? Your real numbers. So it's very important. So here I can say 0, 1, 2, here 0, 1, 2, 3, here -1, -2, -1, and -2. So as I said, your y-axis is your imaginary numbers, your x-axis is your real numbers. So as you can see, my real number is 2. So where's your 2? Your 2 is there. That is your 2. Then my imaginary number is 2 also. So where's your 2? It's there. So which means, as you can see here, they will meet somewhere here. Yeah. This is where you draw your Gantt diagram, as you can see. Exactly. Now where is going to, so what is your angle? What is your argument? Since we are focusing on the argument, which means your argument, your angle, it's in the first quadrant. That is the thing that you must know, which is very important. So which means our angle here, which is the argument, is already in the first quadrant from the x-axis. So we need to find this theta. That is your argument. So let's do it. I hope you did understand, guys, here. So to find our argument here, it's going to be, the simple formula is tan inverse, since I said it's b over a, your b, which is your imaginary is 2, then your a, which is your real, is also 2. So it's tan inverse, which means our argument here is tan inverse of 1. You can use a calculator here. Tan inverse of 1, you get 45 degrees. But usually, in most of the cases, you must convert it to a. You need to convert it to radians. So I'm going to show you how to convert from degrees to radians. Let's do it. So since I said pi, it's 180 degrees. So how do you convert our 45 degrees to radians? Here it's going to be simple. Let's say I want to find what? It's x. It's unknown. I need to find that x. You can cross multiply, or you can apply the method that you understand. If you cross multiply, it's going to be what? 45 pi multiplied by 45 degrees is 45 degrees. Pi equal to x multiplied by 180. It's 180 degrees x. So how to find the x divided by what? By 180 degrees and by 180 degrees. So this one in 180 we cancel, which means our x, your x, which is your in radians, so it's 45 degrees minus 180. Yeah, so what you get here, you are going to get 1 over 4 pi, which means it's pi over 4. So that is it. This one will become your angle in radians, which is your argument. Okay, thank you for watching. I'm also kindly, for your last favor, guys, can you subscribe to my channel so that I can post more videos of this. The next video, we are going to revise, we are going to discuss our question 2 on the assignment. Thank you.